want to come in and learn about some amines and amino acids? Right guys, first we're going to learn about amines. Now, if we're going to be handling amines, you need to be wearing goggles. Okay, now I'll pick up the ones we prepared earlier. Here are our amines. We have 3 different sorts of amine. This is our first one. This is a primary amine. It has 2 hydrogen groups on the nitrogen and then 1 methyl group here. That makes it primary because it's attached to 1 methyl. Or in fact, any other carbon group. This one is our tertiary, so let's go next. This one is our secondary amine. It has 2 methyl groups and 1 hydrogen bonded to our nitrogen group. So that makes it tertiary. Tertiary? Secondary. Makes it secondary. I'll get it right this time. Secondary because it's got 2. This one is our tertiary. Now, this nitrogen actually has its delocalized electrons in this one, so it could have another bond, but it is saturated with 3 methyl groups, which is what makes it a tertiary. 3. Okay, now we're finished playing with our amines. I'm going to put them away, which means put my glasses back on. Alright, now, this is the most important part of any amine. It's the lone pair on the nitrogen. Because this is the lone pair that allows them to react. In some cases they react nucleophilically, other times they can actually act as a proton acceptor, so as a base. Now, this is our primary amine, because it has the 1 methyl group, and that means it has a relatively strong, compared to ammonia, bond that could be formed here. So it will displace none of these compounds. This is our tertiary. This one's much stronger. It has these 3 methyl groups, which are much more stable, so they actually don't have as much interest in pulling the electrons away from the nitrogen group. Whereas this one, it's still stable, but that one still wants to pull it a little bit. These 2 are pulling it both. This one is quite weak in comparison, because these hydrogens aren't very stable. They're all kind of grabbing at this electron.
Yes, science!
Right, now I'm going to show you a nucleophilic reaction that takes place using an amine. This is actually ammonia, and it is going to react with our, what is that? That is bromomethane. Bromomethane. I've had another thermotypicus from the camera. Right, and so this lone pair, this very important lone pair, it's quite weak in this one, but it still works. It's going to attract it to this delta positive carbon, and this bond, this electron in the bond, is going to go into the bromine. There, it goes over here. Suddenly we have a large compound as formed by this nitrogen bonding to this carbon. And this bromine has disappeared. And then, the only problem is that that is an N+. And it doesn't want to be N+. So, what we have to do, this hydrogen goes away, possibly bonded onto one of these molecules, another one to make an ammonium salt, maybe not, we'll see. And that means that this N is no longer positive, and that is now our stable product, which is ethylamine, I believe.
1.
Right, these are the 3 ways of forming amines. This is the first way, the way we just covered, using that mechanism, which gives us a mixture of different amines, primary, secondary and tertiary amines. This, reduction of nitriles using lithium aluminium hydride, is a reaction that involves this cyanide ion that has been bonded to this methane, and it will just basically add hydrogen reduction to form us a ethylamine. Yeah, got another nod, that's good. Right, and then the third way is aromatic amine reducing nitro compounds. So, we have our nitrobenzene, that's the one, not nitrophenol, nitrobenzene, and this O2 group is removed and replaced with an H2 group by reduction, which gives us our phenylamine. Now, if one of our lovely amines were to fuse with a carboxylic acid group, we get what we call an amino acid. Now, you'll recognise this lovely amine group, this NH2, but then we have a CH and we've got an R. You might not recognise an R, that's a new group for us. The R group is referring to any compound, well, any within a few, I think there are around 20 different groups of atoms that go together to create the R group of our amino acid, and that kind of, it shows its properties. That's where the properties are. Then, on this end, we have our, familiar probably from our other groups video, our carboxylic acid group with our C double bond O and then our OH group. And this is the building block for all proteins. Now, this can react either as a base or as an acid. If this side wanted to react as a base, another hydrogen would come along and bond to the double bond that is still here on this nitrogen group. So, to this double free electron group on the nitrogen there. So that would form our base, and actually now it can react as an acid, because if it lost that nitrogen, it would be reacting as an acid. Then, our carboxylic group. This O here, in basic conditions, would want to lose that hydrogen. So, the electron from hydrogen goes over to our oxygen, making it minus, and that hydrogen is now moving around just as positive, which actually means it's just a proton. So that is a proton donor, which makes it an acid. Now, as a result of our acidic conditions and our basic conditions, we've actually formed a Zwitter ion. And a Zwitter ion has 3 hydrogens and a nitrogen here to make our positive nitrogen. And then it's got the lack of an H over here, which makes it a negative oxygen. Now, we're going to need these back, because we're going to move on to peptide bonds. Right, formation of a peptide bond. Peptide bonds are what hold chains of proteins, or chains of amino acids to form proteins together. And it's formed when the OH of a carboxylic acid group on our amino acid bonds with the H on the amine group of another amino acid, which would be around here. We're not allowed to draw on this wall. So, this hydrogen and this OH group would bond together and form H2O. So that makes us water, right there. And then, now, that nitrogen and that carbon both want to bond because they've lost their bond and they're only wanted to 3 here and 2 here. So they form a bond with each other. So that would form a dipeptide, one peptide here, one peptide here. And if you wanted to form a tripeptide, we have a look at this side. So this is the carboxylic acid side. So an amino acid, it's like a domino, it can do on both sides. And the same thing happens here. This OH group reacts together to form our H2O and get a brand new bond. Unfortunately, I remember at both ends of this table, which is an excellent setup. And there we go. But they can also be broken down. Now that was a condensation forming there because we got H2O. Now to break one of these bonds would be hydrolysis. And you do that by adding back our H2O into here. And that H2O would break this bond, react with our carbon to form a OH group, and our nitrogen to form an H group. And suddenly, they are again separate amino acids, and we've lost the water, which is why it's called hydrolysis, breaking using water.